Review number 15 that we have. A ball is thrown upward from the top of a 112-foot building at a speed of 96 feet per second. The ball's height above ground can be modeled by the equation h of t equal to negative 16t squared plus 96t plus 112. Part A, when does the ball reach the maximum height? And Part B, what is the maximum height of the ball? Both of these can be answered by one thing, the vertex. Each part of the vertex will answer either A or B. So let's deal with the vertex. Negative B over 2A. We've seen it now many times. Our B value is 96. So we have negative of 96 divided by 2 times A. A is negative 16. Looks like we're going to have negative 96 divided by negative 32. And you know, if you take 32 times 3, you get 96. And so the answer is going to be 3 for that one. As in 3 seconds after we launch the ball, it will reach maximum height. So that actually answers part A. When does the ball reach maximum height? 3 seconds. Now the other part of the vertex should answer the actual height itself. So we put 3 into the equation. So we have negative 16 times 3 squared plus 96 times 3 plus 112. Well, 3 squared is 9, and 9 times negative 16 is 144 to the negative, plus 96 times 3, that's 288, plus 112. Negative 144 plus 288 is positive 144, and plus 112 on top of that is 256. So it looks like 256 is the maximum feet this ball will go. FT or feet, either one of those is just fine. All right, when does the ball hit the ground? Well, the ball hits the ground when its height is 0. In other words, 0 equals negative 16t squared plus 96t plus 112. The good news is all of these are divisible by negative 16. Why negative? Because I want my first value to be positive. So let's go ahead and divide everything here by negative 16. So that's going to give us 0 equals positive t squared. 96 and 16 is 6. So it's going to give us negative 6t. And 112 divided by negative 16 is actually minus 7. This is going to be factorable too, right? Because the factors of 7 that make 6 are 7 and 1. So 0 is going to equal t minus 7 times t plus 1. Which means that t is either equal to 7 seconds or t is equal to negative 1 seconds. Obviously, t can't equal negative 1 seconds. And so, but it can equal 7 seconds. So when does the ball hit the ground? 7 seconds. That's how long its flight is for. D and E and F could all be answered by actually graphing this equation here. So let's go ahead and graph it right here. We didn't talk about the y-intercept, but we know if we go back to the original, the y-intercept is 112. And again, because we're launching it, this is the place where our graph actually starts. Our vertex is at 3 and 256, so somewhere up here is even 256. And somewhere here is about 3 seconds. 256. Looks like it's going to do that. And then at 7 seconds, we know it also hits the ground here because that's as far as it goes. So we can now draw this graph here like that. It doesn't really have a back half of this graph, right? Because there is no negative times here, right? Remember, the x-axis here represents time. And the y-axis represents height. So it doesn't have negative time. So our time starts here at 112 and then goes from there downward. So that answers part F. And in fact, we've got A through C on the graph here. We've got that represented. So let's talk about the increasing and decreasing. So our graph is going to increase from x equals 0 all the way to x equals 3. So our increasing is 0 to 3. Our decreasing then is from 3 to 7. Because it can't get below 7. right? If this was a normal graph, we'd say positive infinity or negatives infinities, and we'd have infinities, but this is a real life graph, and it can only go within the given constraints. Finally, let's explain the restrictions on the domain. The domain is t must be greater than 0, or if you will, it has to be 0 to 7. Simply because you can't have negative time. And the ball hits the ground after 7 seconds. And there you go. We've answered question 15 from the review packet.